Good afternoon to all. This is Srinivaslu. I am currently pursuing BTech second year in Srinivasa Ramanujan Institute of Technology. Now I am here to tell a concept about Bayes theorem. So topic name is state and prove Bayes theorem. Let's dive into the topic. Introduction to Bayes theorem. So what is Bayes theorem? Bayes theorem provides a way to update the probability of an event based on new evidence. It is fundamental in statistics, machine learning, and decision making process. The theorem relates the conditional and marginal probabilities of random events. Statement of Bayes theorem. So, Bayes theorem has one statement, and this statement is let E1, E2 up to En be n mutual, exclusive, and exhaustive events in a sample space S, such that P of Ei greater than 0 for I equals to 1, 2, 3, 4 up to n. A is any event in which P of A greater than 0 if P of E1, P of E2 up to P of E1 and P of A by E1, P of A by E2 up to P of A by En are known, then P of Ei by A equals to P of A by Ei into P of Ei by P of A by E1 into P of E1 plus P of A by E2 into P of E2 plus P of A by En into P of En. So proof of Bayes theorem. We know from conditional probability P of Ei by A equals to P of Ei intersection A by P of A. Also, so P of Ei intersection A equals to P of Ea by Ei into P of Ei. So P of Ei by A equals to P of A by Ei into P of Ei by P of A. So by the law of total probability, P of A equals to P of A by E1 into P of A by E1. So P of A by E2 into P of P by E2. So up to P of A by En into P of E by A by En. So substituting this value of P of A. So finally we get P of Ei by A equals to P of A by Ei into P of Ei by P of A by E1 into P of E1 plus P of A by E2 into P of E2 up to P of A by En into P of En. So hence proved. Hence Bayes theorem is proved. So applications and significance of Bayes theorem. Bayes theorem is widely used for updating probabilities in medical diagnosis, spam filtering, and more. It provides a vigorous method to revise belief when new data becomes available. Understanding and applying Bayes theorem is essential for probabilistic reasoning and statistical inference. So let's see one example related to Bayes theorem. So in a bowl factory machines, ABC manufacture 20, 30 and 50% of the total of their output and 632% are defective. A bolt is drawn at random and found to be defective. Right. So in a bolt factory, there are three machines A, B, C and manufacture and product of the machines are 20%, 30% and 50% of the total output. So 3% from A, B, 6% from A and 2% from C are defective. So calculate the probability that is manufactured from first mission A, second mission B, third mission C. We have to find probability that is manufactured from mission A, mission B, mission C. So our solution, let P of A 20 by 100 because its manufacture rate is 20%. So we write into 20 by 100. So P of B 30 by 100 and similarly P of C 50 by 100. Let's denote. D denote the event of the bolt is defective. P of D by A 6 by 100. P of D by B 3 by 100. P of D by C 2 by 100. These are defective. So using Bayes theorem, P of A by D equals to P of D by A into P of A, P of D by A into by P of D by A into P of A plus P of D by B into P of B plus P of D by C into P of C. So first, probability that defective bolt is from mission A. So substitute the above values in above formula. So finally we get 12 by 31. Probability the defective bolt from B. So similarly substitute the values and you get 9 by 31. So similarly to mission C, so and we get 10 by 31. Final answers are bolt defective from mission A is 12 by 30, from B 9 by 31, C 10 by 31. And conclusion. So hence by applying Bayes theorem we concluded that among the defective bolts the highest probability is that the bolt was manufactured by mission A, that is 12 by 31, followed by mission C 10 by 31 and mission B 9 by 31. This shows that even though the mission C produces the highest output, but mission A contributes highest proportion of defective bolts due to its higher defective rate. So thank you for giving me this opportunity.